Question is connected with the isotope ratio measurement, and here to the question, since we are in a metrology workshop, what is a traceability chain? What is a primary standard for the isotope ratio measurements?
You know, I'm going to let Zoltan answer that if he is on. I believe I saw him earlier. Zoltan, are you there?
Yes, I am here. Okay. Hi, Dirk. Good morning, everyone.
Hi.
So isotope ratio mass spectrometry, usually we express our results in amount ratios. So it's a purely SI traceable approach based on basically mole. However, for practical reasons, most of the traceability in isotope ratio measurements are for artifact scales. So basically reference materials against which we express relative isotopic compositions, like the carbon delta scale or some other artifact scales.
Yeah, may I make a comment, because we have also discussed this in the preparation of the workshop, that this is, from my point of view, a difference between the two words, the CCRI and the CCQM word. So the CCRI2 traceability is mostly traceable to primary measurement methods, whereas, as you said, that the CCQM isotope ratio measurements are typically, or in most cases, traceable to artifacts and to reference materials, so to artifacts where by definition or by convention, for several reference materials, isotope ratios have an uncertainty of 0. So it is stated as the reference. I mentioned this because I think also in this workshop we have to see the difference in the work and in language, or the difference in the roots, and this, I think, from my point of view, is one of the major difference between the two communities. So that's a small comment from my side.
Thank you. It's indeed a very interesting issue to explore. I would like to add that there is only one exemption under the MRE register for non-SI traceable measurements, but this artifact traceability for isotope ratios under the CIP MRE. So yeah, so isotope ratios are registered as exemptions. Yeah.
Yes, I think
I'd like to
have a whole workshop on that.
Yeah, I'd like to expand on that just a little bit, and I guess emphasize what Zoltan just said. The only exception to traceability to the SI is the use of the delta scales in isotope ratios. So when we're measuring elemental mass fractions, in fact, the traceability does come back to the SI, and often through primary methods. So ultimately, they do trace back to primary methods in some way. Sometimes the traceability route is long, depending on the case at hand. But I think that difference between the two communities is not as big as it might appear. It only comes into play with the isotope ratios.
This is Jackie, I'd like to second what Mike just said. The traceability exception really only applies to the stable light isotopes where they're using artifact-based scales. For the higher end of the periodic table, that's not the case. And typically you do have traceability to the SI through the mole, as Zoltan had mentioned. So.
Thank you, Jackie. Simon, I know you have your hand up, but I want to ask Richard if he's following up on this particular discussion.
Yes. Just very quickly, I wanted to say that not too much longer in this workshop, we're going to have very focused discussions on just these kinds of issues. So we can get into this to some detail.
Great, thank you, Richard. Simon, you have a question or comment?
Yeah, can you hear me now?
I can hear you now.
Okay, so I'm a stakeholder, not a metrologist anymore.
You are always a metrologist. Once you're a metrologist, you're always a metrologist.
Oh dear. Yeah, Michael mentioned in his presentation about the about detection limits. I would like to raise this question in that, as far as I can see, the radionuclide measurement community and the mass or mass spectrometry community appear to calculate detection limits or characteristic limits, call them what you will, in two fundamentally different ways, and even the vocabulary is different. And I think, I mean, this isn't traceability, but I think we need to kind of come to some kind of common approach here, because it's just done completely differently. So is there any is there any sort of anything going forward on that at all?
Simon, when you say they are done completely differently, different approaches, are you suggesting that the results will be also different?
How long have you got?
Not 3 days.
The characteristic limits for radioactivity measurement are pretty much controlled by an ISO standard, ISO 11929, which we all know and love. As far as I can see, and my background's radioactivity, not mass spectrometry, but the ISO 11929 talks about the decision threshold and the detection limit. It makes no mention of a quantification. As far as I can see from mass spectrometry, you use a limit of detection and a limit of quantification, and they're calculated very differently to that in ISO 11929. So there's kind of a little bit of a mismatch there. Mm-hmm. Because we haven't got 3 days, I'm not going to tell you how they calculate it, but believe me, it is different.
Oh, I believe you. So I don't see anybody else willing to dive into this particular swimming pool. What I can tell you is that in our steering committee meetings in preparing for this workshop, many different topics came up as to what would be helpful to discuss. And this specifically did come up. I'm trying to remember who brought it up. It may have been Richard, it may have been Dirk. But in any case, we did decide that for this particular workshop, because we do have only the 3 days, and yeah, we wouldn't be able to get into it. I do, however, want to assure you that it is something that we have been discussing, and it is something that needs to be considered. Does anyone else have anything more to add to that? No?
Maybe I'll add one small point, and that is that in the chemistry side of things, there is no ISO standard, as far as I know, that says how you calculate a detection limit or a quantification limit. I might be unaware of something, but I don't remember ever seeing anything like that. There are accepted ways of doing it, and there's not just one accepted way. So there are a couple of competing ways, but they do essentially end at the same number. They get out at them in different ways, but the detection limits that you calculate or the quantification limits you calculate are not dramatically different.
Thank you, Michael. Angelique, I see your hand is up.
Good afternoon, Lisa.
Good morning, Angelique.
Oh, yes, sorry. Yes, I just want to support Mike to say that I think we really need to tread so slowly, because in the two groups, I think the starting point would be the definition of the measurand. Our definitions of the measurand are completely different, and therefore we really need to take it slowly to meet each other halfway and to come to a common understanding. Because yes, as Mike said, although we don't follow an ISO standard, there is a kind of acceptable approach in terms of measuring limits of detection in chemistry. But I think if we might get stuck in terms of terminology between the two groups. So we really need to try and explain to each other what we're actually talking about. And we need to keep in mind the difference in the definition of our measurands, because I think that way we will actually realize quite quickly that we're not that different, and there is a lot of common ground.
Yes, thank you. I think that is very well observed. I'm hopeful that this workshop is not the last time we speak with one another. And as I said in my presentation earlier, I really look forward to this being the opportunity to start the cross communication with each other. Simon, you still have your hand up. Did you have more to say?
Yeah. I mean, I just agree with Angelique and Michael, and I don't want to get bogged down in this because it's been debated for decades, but I think it's something that we should sort of have on the list of things to address at an appropriate time.
Thank you. My notes, I'm showing it as big topic. How about that?
Oh, you're so wonderful.
I know. Thank you. Okay, great. Thank you so much. This has been an excellent discussion.